In section 10.1, we're going to talk about radical expressions and radical functions. So what I have before you is the general structure of a radical expression. Every radical expression has three components: the index, the radicand, which is the expression under the radical symbol, and of course the radical symbol or radical sign itself. So we got 1, 2, 3 pieces of every radical expression. Now the radicand here that I have an expression, usually we have, like in algebra, we have algebraic expressions under the radical sign, but it can also be as simple as just a number, like, you know, a positive, negative number, depending on the index. So let's define what we mean by square roots. Okay, so this is our first definition of a square root. A simple, straightforward definition: a number c is the square root of a if you square c and it becomes a. Okay, that's all the definition is. So for example, let's say we want a square root of 16. Well, because 4 squared is 16 and negative 4 squared is 16 also, so there are 2 square roots of 16. 2 square roots, one positive, one negative. Now in our work, we acknowledge the negative, but in our work we are primarily interested in the positive square root. Now the positive square root is also called the principal square root, and we have agreed to use the radical symbol without the index to represent the principal or the positive root. So here I have an example. Square root of 100 is 10. Now if you look at, by the way, the index here, for every square root, their index is 2. But if it's 2, for simplicity, we simply don't write the index. Okay, but it's always there, just so you know. It's there, but we don't write it. So that's what the square root is. Now, a square root function, and let's take a look at the square root function. A square root function looks like this expression: f of x is equal to square root of x. That's called the square root function. Now let's plot some points and actually graph this. Okay, now remember, f of x and y are the same thing when it comes to graphing. Okay, so before I actually do this, let's take a look at another example. Suppose now instead of 100 I have negative 100, and I want to find the square root of negative 100. Now for this, as you can see, because you square a positive number or a negative number, the outcome is going to be positive. So it is impossible, therefore, to square a real number such as 10 or negative 10, square it and get a negative number. So because this will never happen, that you square again a positive or negative number and it becomes negative, therefore we're going to say this answer is not real. That means we cannot find real numbers that are capable of doing it. Now we notice we don't say like it does not exist or no answers, anything like that. We simply say not real. The way we state this, not real, kind of leaves the door open for later on we're going to come back and see how we can remedy this. But even when we come back later on to remedy this, to correct it, it turns out the answer is not real. There's no way out of this not real. It's just there are another category of numbers that we talk about, imaginary numbers, and then we'll be able to work with expressions like square root of negative 100. Okay, so, and the reason I mentioned that just jarred my memory is because when we try to graph the square root function, for example, I'm not going to let x be negative 1. Why? Because the square root of negative 1 is not real. Right? A number times itself cannot be negative 1 by definition of a square root. So I'm not going to choose negative 1. So we're going to cross that out. Okay. The things I can choose is, I'm going to pick 0 1, and you can go 0, 1, 2, 3, 4, but I'm going to pick smart points, 0, 1, 4. Now plug in a 0 for x, you take square root of 0, and that will be 0. Plug in a 1, the square root of 1 is 1. Plug in a 4, square root of 4 is 2. So we have 3 points on the graph of this function. If I was to choose another number, by the way, what do you think it would be? Notice y is 0, 1, 2. I want y to be 3. So square root of what should be 3? And 9, correct? I mean, you could choose x to be 5, 6, 7, 8, whatever, but if I do that, then I need a calculator to get those numbers out of the calculator, their square roots. So let's graph this. Here's your 0, 0. This is 1, 1. And then 4, 2 here. And then 9, 3 would be right here, actually, near the edge, the border of my coordinate system. And there you have it. Next, what I'm going to do is I'm going to draw a smooth curve through these points. And, oh, that was too smooth perhaps. Let me, I'm not sure what happened there. But here's 4, 2 again, 9, 3. And there. That's going to be the graph of the square root function there. Okay. So that's what it's going to look like. Now, and we're just going to keep track of this later on for our work. But for now, that's all we want to do with it. Okay. And now let's take a look at something like square root of a squared. Square root of a squared is going to be absolute value of a if a is any real number. For any real number a. Okay, and let me move this out of our way. There you have it. So for example, this is working with the square root of something squared. So for example, let's say I have square root of 6 squared. The answer is going to be absolute value of 6, and that is 6. Maybe I should use color here. So a is 6, and here's a. Now, let me make another example. This time, I like a to be, let's say, -5. Okay, and then we square it, equal absolute value of the number I was thinking of was -5, so I take absolute value of -5, and there is 5. Okay, so that's how this works, and the reason or the need for the absolute value. Okay, because a could, this is what a is. If I just write a without absolute value, this would be incorrect, because remember, the principal root is always positive. So just simply copying a down for the answer isn't going to work. Now, if a was positive, then we wouldn't need the absolute value. Okay. Now, let's take a look at next cube roots. Okay, so let's define what the cube root is. Okay, so here I have the definition of the cube root, just like we had it for the square root. This time, the number c is the not square root, but the cube root of a if you cube c and it becomes a. Remember, for the square root, you squared c, it became a. Now for the cube root, you cube it and it becomes a. Now notationally, this is how it's written. The index is 3, the radicand is a, and here's a radical symbol. Now for any index 3 or higher, we need to write that in, because if you don't write it in, then that's implied a square root. Okay. Now here I have a few examples down, like cube root of 8. A is 8 in this case. We're looking for c in our definition. C is a number that you cube and it becomes 8. And in this case, it's going to be 2. Because you multiply 2 by itself 3 times, 2 by 2 by 2, you get 8. Cube root of 27 is going to be what? 3. Because you multiply 3 by itself 3 times, it becomes 27. Now note the radicand in the next two examples. The radicands are negative. We couldn't have that with the square root because the answer was not real, and number times itself cannot be negative, a real number. So, but for the cube root, check this out. If I do negative 2 times negative 2 times negative 2, the answer will be negative 8, wouldn't it? Remember, that is our A, and this is, that is our C. The number times itself 3 times. So that's C, and this is A in our general definition. So the answer is going to be negative 2. So again, it's okay for the radicand to be negative for cube roots, and we don't need absolute value for it. Cube root of negative 64, this time if you multiply negative 4 by itself 3 times, you get negative 64. So the answer is negative 4. Okay, and that's how the cube roots work. Now what if, let's say I have cube root of 17? For something like that, we use the calculator. Okay, so don't worry about learning the procedure on how to do cube roots by hands. Okay, let's take a look at our cube root function now. So we're going to add a function to our gallery of functions. Now the cube root function is one that looks like this. F of x is equal to the cube root of x. Okay, and in this case, I'm going to again plot points, and we are allowed negative numbers. So I'm going to choose what we call perfect cubes, numbers whose cube roots are going to be a whole number. Okay, so for example, I'm going to pick negative 8, and then I'm going to pick negative 1, and then 0, 1, 8. Those are all perfect cubes. Okay, now negative 8, cube root of negative 8 is negative 2. When x is negative 1, that's cube root of negative 1 will be negative 1. Any root of negative 1, as long as the index is odd, the answer is going to be negative 1. The 5th root of negative 1 is negative 1. The 7th root of negative 1 is negative 1, and so on. All the odd indices. So that's going to be negative 1. And then 0, cube root of 0 is going to be 0. When x is 1, cube root of 1 is 1. When it's 8, cube root of 8 is 2. And we have enough to plot points here. So negative 8, negative 2 is going to be a point here. Negative 1 is going to be here. And 0, 0 is here, 1, 1 here, and 8, 2 is going to be here. Okay. Okay, so now that we have our points, we can connect these dots together, and you kind of imagine what this graph is going to look like. It's going to be very steep going in this direction. Let me actually redraw it. Okay. No, I'm not sure what happens there. 0, 0, 1, 1. Okay, so let me draw right through it this way, and that portion of it goes like that. So this is how the graph's gonna look like. I really butchered it, didn't I? Okay, and there you go. That part of it is kind of like a square root. And this is the mirror image about the origin. Okay, and there you go. So that's what the graph's going to look like. And we're just going to make a note of that going forward. So we have now both cube root and square root functions graphed out. Okay, so let's take a look at actually some examples here. Okay, some of the exercises from your book. So for instance, let's take a look at number 10. Okay, exercise number 10. Here we want to find all of the square roots, both square roots of 81. So both of them. That means a number squared is 81. That's going to be 9 and negative 9, right? because we want all of square roots in this example. We are told specifically that. Okay, now for something like number 18, we're using the radical symbol, square root of 144, and that's going to be 12 actually, right? Because remember, the radical symbol is implied principal root. For something like number 20, I have negative square root of 100. Now, remember, the radicand, what's under the radical sign, when it's a square root, cannot be negative. But the negative on the outside is okay, as long as it's not inside. Okay? So square root of 100 is 10. The answer is negative 10. Okay, we just attached the negative in the end. Something in the way of a fraction, let's say, number 22, we have a square root of 4/9. This time a fraction times itself is 4/9, so that's going to be what? 2/3. The reason, because 2/3 times 2/3 is 4/9. Okay, and there we have this one. Now, let's take a look at another example. In this example, let's take a look at number 36. Now, in number 36, we're given square root of 16t squared. Okay, and the expression reads that the question reads simplify, and we're told further that variables may represent any real number. Okay, because t could be any real number, so if I just say square root of 16t, if I say, well, that's 4t times 4t, isn't it? 16t squared. So the answer is 4t. However, this answer has the potential to be negative, doesn't it? If t is negative, right? If t is less than 0, then 4t will be less than 0. That means this answer will be negative, which defies again the definition of the principal root. So it is for that reason that we put absolute value around it. And when we have a number times a variable inside an absolute value, we're actually allowed to remove the number outside of the absolute value. So this will be the final answer. It's 4 times absolute value of t. Okay. Now, let's take a look at something like number 40. In number 40, we have square root of a plus 3 squared. And again, for this one, just like the previous one, t squared, square root of t squared was t. Well, square root of anything squared is itself, right? So this is going to be a plus 3, because a plus 3 times a plus 3 makes a plus 3 squared. Now again, this has a potential to be negative, right? So for example, if a is negative 5, the answer will be negative. You see that? Therefore, for that reason, we have to put absolute value around it. Otherwise, it's going to be incorrect. Now, when you have addition subtraction, we cannot do absolute value of a plus absolute value of 3. Okay, we're not allowed to do that. So we're done with this one. Only in multiplication we can bring the number outside the absolute value. Now for something like number 42, in number 42 we have x squared negative 4x plus 4, and then square root of that. Okay, so for this one, I'm not allowed to take individual square roots with addition subtraction. So here's what I mean. You cannot do this if that's what you were thinking. We're not allowed to do that. There's no property of radicals that will allow us to do that. So one thing we have to do is a little bit of it's a subtle problem, I guess. The x squared minus 4x plus 4, we can actually factor this. 2 number that multiplies to positive 4 and combines to negative 4. That would be negative 2 times negative 2 makes 4, and negative 2 combined with negative 2 makes negative 4. So there you go. Actually, we can rewrite the radicand as x minus 2 squared. And now this looks kind of like that one, doesn't it? Right, once we manipulate it a bit. And the answer to this is going to be absolute value of x minus 2 again. Again, the reason for absolute value is because the answer has the potential to be negative. And the symbol, the radical symbol, square root symbol, means positive root. Okay. Now something like, for example, number 48. Square root of negative 16. What do you think about that one? We cannot simplify this, right? So this one we're just going to say not real. It cannot be simplified. Okay. Now something in the way of a, let's say, cube root, something like number 50. In number 50 we have negative cube root of negative 1000 is. Now, cube root of negative 1000, right? Cube root of negative 1000 here. This is just going to be negative 10. And then remember, there's a negative on the outside. So it's going to be negative on the outside. And the answer to the cube root is also negative 10. The double negative make the answer positive 10. Okay. Let's take a look at something like number 74. I'm trying to look through and find exercises similar to your homework. Okay, so let's say I have something like square root of 25t squared. And the question here reads simplify. Now for this one we have instructions that says assume no radicands were formed by raising negative quantities to even powers. Okay, in other words, the variable cannot be negative. The variable is positive. We're told that. Let me just write that. Assume that the variable is positive. Well, if the variable is positive, square root of 25t squared is just going to be 5t, isn't it? And there's no way this expression is going to be negative, so the answer will be positive. Notice here, there's no need for absolute value in this one. Okay. So there you have that one, number 74. So now for something like number 78, let's say, in number 78 we have negative 10a quantity squared square root of. Okay. Now for this one, if we just say the answer is negative 10a, but see here, a variable is positive, right? So a is positive. So this will be negative, wouldn't it? Negative 10a will be less than 0, meaning negative, wouldn't it? So what do we need to do? We need to actually write this as 10a to force a positive answer out of it. Okay. So negative 10a squared is equal to it would be square root of negative 10a if we didn't know what a is. But if a is positive, then the answer is going to be 10a in this one. Okay. And one way you can actually justify this is also, look at it. Negative 10a squared means negative 10a times negative 10a. 10 and 10 makes 100. A squared. See, 100a squared. And this, again, we're back to looking something like this one. So for that, the answer is just going to be 10a. There you go. That's going to be the answer. That's the answer. 10a. Okay. So again, notice in here, you got to be careful because we were told a is positive. So this isn't allowed. Okay, that was number 78, and I think that's probably good enough for our work. Let's do one last one, number 86. Number 86, we have a square root of a to the 14th power. Now this time, think about an expression times itself give you a to 14th power. Well, if we look at a to the 7 times a to the 7th, how about that? Remember, the multiplication rule of exponents tells us we can choose a common base a and add the exponents. So that is the answer. A to the 7th will be the answer to the square root. Okay. And with that, we are done with this section. So I'm going to stop the video now.